Welcome back, everyone. Today we're going to talk about how to simplify radicals, and this is the first lesson on radicals. Now, I mentioned before that a radical is just a square root or a cube root or a fourth root or a fifth root. It's your roots, right? So the word radical is referring to the symbol of square root, cube root, etc. So it's simply, in this class, we're only going to focus on square roots and cube roots. So if you see that symbol is referred to as a radical. Now the word radicand, you're going to hear, the radicand is basically the expression inside the radical. So the stuff inside the radical. I'm going to write it as the expression inside the radical. So for example, if I have the cube root of 3x, 3x is the radicand. Or if I have the square root of 2ab to the third, 2ab to the third is your radicand. Okay? Now, before we start simplifying them, we need to understand some things about multiplying and dividing radicals. If you have two radicals, and today we're specifically going to be focusing on square roots, but I'm going to refer to them as radicals. So if you have two radicals that have the same root, so they're both square roots, you can multiply and divide the stuff inside the radicals. So here, the square root of 3 times the square root of 5, because they're both radicals, you can multiply the radicands together. So 3 times 5 is 15, and that would give us the square root of 15. And that's all we can do. We don't know what the square root of 15 is, so we would just leave that as the square root of 15. For letter B, the negative signs in front of the radical are just meaning that these two radicals are negative, so we follow the same rules. A negative times a negative would be a positive. So the negative square root of 2 times the negative square root of 7 would give us positive square root of 14. And 14 is not a perfect square, so we really can't do anything with that. Now letter C, I have the square root of 7 times 2. The square root of 7 is a radical and 2 is an integer. So we can't actually multiply the 7 and the 2 together, but what we would do is we would write this as 2 square root of 7, just like that. And then letter D, we have 6 square root of 5 times negative 2 square root of 6. So 6 square root of 5 means 6 times the square root of 5, just like and negative 2 times the square root of 6. That's what that means. But if I want to put those together, I can put my integers together and I can put my radicals together to make one whole expression. So 6 times negative 2 would give me negative 12. And then square root of 5 times the square root of 6 would give me the square root of 30. So I would get negative 12 square root of 30 there. And that's how you would say it. Letter E, the next row is all division problems. So we can do the same thing. So letter E is saying the square root of 10 divided by the negative square root of 5. So all we do is divide the radicands, and that would give us 2. And it's negative because the positive divided by negative is a negative, and that would end up giving you the negative square root of 2. Letter F, that's just going to give us square root of 2 because 10 divided by 5 is 2, right? So it's the square root of 2. Now letter G, the square root of 12 over the negative square root of 2, we can't reduce that because negative 2 is an integer and the square root of 12 is a radical, and you can't combine radicals and integers, right? So we would just leave it like this. The only thing I would say is that typically we don't leave our negative numbers in the denominator, so you could pop it out to the front and just call this the square root of 12, the negative square root of 12 over 2, and leave it like that. You could also pop the negative onto just the top number, but that's the most simplified way of writing it. Now letter H, we have integers and radicals, right? So you just divide the integers together. The 8 divided by negative 2 is negative 4. And then the square root of 12 divided by the square root of 6 would give you the square root of 2. Now I'm sure the multiplying and the dividing seems easy enough, but it's important to remember that radicals can go with radicals and integers can go with integers, and that's it when you're multiplying and dividing. Adding and subtracting, we have different rules. So you have to understand that in order to understand how to simplify radicals. So in the radical unit that we're doing, there are 3 rules to making sure a radical is simplified. And specifically, again, we are just talking about square roots today. So the first condition is that an expression with radicals is in simplest form when the radicand contains no factors that are perfect squares. So for example, if we're looking at a number, we are asking ourselves, can this number be divided by any perfect square? So think through your perfect squares, like other than 1. 1 goes into everything. So we're thinking 2 squared is 4, so 4 is a factor. 3 squared is 9, 9 is a factor. 4 squared is 16, 16 is a factor, and so on. So looking at the radicands that you see, the radicals that you see here, take a moment, look at the radicals, decide which ones are not in simplest form. So take a moment, stop the video, circle them. Which ones do you think are not in simplest form? So hopefully you saw 50, the square root of 50, would not be in simplest form because 50 can be divided by 25, and 25 is a perfect square, right? So this has a factor of 25 in it, okay? 72 is not in simplest form because 9, 4, and 36 all go into 72. So factors of 4, 9, and 36 go into 72. All of those are perfect squares. All right, the next row, 121, is a perfect square, right? The square root of 121 is equal to 11. So this one is already a perfect square. And then the square root of 8, 4 is a factor. And then the square root of 125, 25 is a factor. Now, there are 2 divisibility rules for 2 of the perfect squares that I know of, 4 and 9. So 4 and 9 are really common perfect squares. And since we're going to be trying to find factors of 4 and 9, it's really helpful to know if a number is divisible by 4 or 9. So there are these rules that maybe you know or maybe you don't know, but a number is divisible by 4 if the last 2 digits are divisible by 4. So if the last 2 digits are divisible by 4. So for example, let's take the number 1024. The last 2 digits of 1024 are 24. And since 24 is divisible by 4, that means this entire number is divisible by 4, which means this is not in simplest form because 4 goes into it, right? Another example might be the square root of 81,480, right? 80 is divisible by 4. And since 80 is divisible by 4, that means 81,480 is divisible by 4. So that's helpful to know, right? The other rule, a number is divisible by 9 if the sum of the digits is divisible by 9. So if the sum of the digits, this is the same rule for 3 as well, but we are interested in 9 because 9 is a perfect square. So for example, the square root of 72, if you think about that, that's got 9 that goes into it because 7 plus 2 is equal to 9, right? So you just add the digits. The square root of 5,049, because if you were to add 5 plus 0 plus 4 plus 9, you get 18. And 18 is divisible by 9. And we can even take that even further, right? 1 plus 8 is 9, and 9 is divisible by 9, right? So if you're really trying to figure out if a number is divisible by 9 by just looking at it and without using a calculator, you just add the digits. That's all you do. So now let's go ahead and start talking about how do we simplify these radicals. Well, my first step always, whenever I say simplify a radical, it is a good idea to have a calculator And it's a good idea to have your perfect squares written down on your paper. So for example, we're just going to do that, right? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. Now, obviously there are more, but usually 1 through 144 are going to help us. Now, because 1 goes into everything, we are not counting 1 because the square root of 1 is 1. Okay? Now, when I look at a radical, what I'm going to do, so starting with the square root of 50, I'm going to go through and I'm going to ask myself, is there a perfect square that goes into 50 evenly? And the answer to this is yes, right? 25, right? So what we do is we take the square root of 50 and we divide it by that radical, or we break it into 2 factors, right? So we're going to rewrite the square root of 50 into the square root of 2 times 25, which really means the square root of 2 times the square root of 25, right? Now, we can simplify this further because we know the square root of 25 is 5, right? 5 is an integer. So I'm going to make this 5 square root of 2. Now, if you were to go to your Desmos calculator and type in the square root of 50, you would get an irrational decimal that would end on the computer, but doesn't actually end, it's irrational. If you also type in 5 square root of 2, you're going to see that the decimals match. It's just that 5 square root of 2 is a simpler form of the square root of 50. Now let's take a look at the square root of 12. It's a little bit simpler, right? When you're thinking of what goes into 12, go over to your perfect squares list and start. I often just look at my numbers and is 12 divisible by 4? Yes. 4 times 3 gives me 12. Now notice there's a negative sign in front, so I'm just going to break this into the negative square root of 4 times 3. Once I do that, I like to circle my perfect square. My perfect square is 4. That is what I'm finding the square root of. The square root of 4 is 2. So that comes out of the radical sign. There's a negative sign out there, so it becomes negative 2. What stays inside the radical is the square root of 3. So that's the simplest form of 12, square root of 12. Now let's look at the negative square root of 480. What I would like you to do is stop the video for just a moment and see if you can find a perfect square that goes into 480. So look over to the left, start dividing 480 by some of the perfect squares on your list and see if you can find one. So there are 2 perfect squares that go into 480, 4 and 16. Now, if you found 16, that problem is going to go a whole lot faster than if you found 4. But my guess is a lot of you were just like, 480 ends in an 80. I know that's divisible by 4. So many of you would probably start with 4, right? So I'm going to take this, I'm going to do the negative square root of 4 times 120, right? Because 480 divided by 4 gives me 120. And then I would find the square root of 4, which is 2. And I pull the 2 out, put it the negative sign in front. So it becomes negative 2 square root of 120. Now the problem here is that I'm not fully simplified. The radicand cannot contain any factors. Well, if you look at that are perfect squares, 120 has a perfect square that goes into it. 4 goes into 120 as well. So if I started with 4, I would have to continue, right? So I would get negative 2 square root of 4 times 30. And then now I have to pull out the square root of 4. The square root of 4 is 2. So I pull that out and I now bring it out and I multiply it because all this is multiplication. We multiply it together. So 2 times 2 is 4. So this would give me negative 4 square root of 30. Okay? So that's one way to do it. Now I'm going to erase this and we're going to do it the other way. Okay? So you don't have to write the other way down, just listen. Maybe you've already done the problem and you did 16. If you found that 16 goes into it before you thought about 4, you would break this into the negative square root of 16 times 30. So then I would pull out the square root of 16. The square root of 16 is 4, and then I would get negative 4 square root of 30. So it is always easier to find the biggest perfect square. So if you find that 4 goes into a number, keep going. See if you can find one that's bigger. Now, take a moment and try the square root of 72 on your own. Now, hopefully you found the square root of 72. It has a perfect square that goes into it. It has 9 goes into it, and 4 goes into it, and 36 goes into it. If you found 36, that's the biggest one. But most of you, knowing your multiplication facts, were probably like 9 times 8, right? So there's 3 different ways we could have started this problem. I'm guessing that a lot of you started with 9 times 8, right? 9 times 8 is 72. The square root of 9 is 3. So then I would pull out the 3, and then you're left with the square root of 8. Now, the square root of 8 has 4 that goes into it. So then I would continue and I would break up the 8 into 4 times 2. The square root of 4 is 2. We pull the 2 out, multiply that with a 3, and that would give you 6 square root of 2, just like that. Now, if you found the biggest perfect square was 36, then you would just do it in one step. 36 times 2. The square root of 36 is 6, and you'd get 6 square root of 2. You also could have started the problem with 4 times 18, and then you would have broken up the 18 into 18 times 2, right? So 3 different ways to do the problem. All right, feel free to stop the video and try the next one. So for this one, you probably found you could have found 2 different perfect squares. 4 goes into 484 evenly, and so does 121. Reminder, we're looking at these set of numbers, right? I don't care if anything else goes into it. I am looking for perfect squares. Now, if you started with 4, you would have the negative square root of 4 times 121. Now, something crazy just happened here. Both 4 and 121 are perfect squares. So that means that 484 was a perfect square, but that's not one we should know off the top of our head. But when we break it up, we can see the square root of 4 is 2. Don't forget the negative sign. The square root of 121 is 11, right? We don't have anything left in our radical. We just multiply and we get negative 22, which means that the square root of negative 484 is negative 22. All right, go ahead and try 540. So go to 540, start dividing 540 by one of your perfect squares, and see if you can find the biggest perfect square that goes into 540. All right, if you're using a calculator, you probably could very easily just start dividing, and you probably found that 36 is the biggest perfect square that goes into 540. So the fastest way to do this problem is to do 36 times 15. And then I'm going to circle the square root of 36 because that's what I'm finding. The square root of 36 is 6, and you would get 6 square root of 15. Now, many of you, if you're doing this in your head, many of you probably were like, well, I know it ends in 40, so it's divisible by 4. So you could have started with 4. You also, if you look at the sum of the digits, 5 plus 4 plus 0, that's 9. So it's divisible by 9 as well. But I want to also point out that if a number is divisible by 4, and then it's also divisible by 9, well, what is 4 times 9? 4 times 9 is 36, right? So 36 is a bigger perfect square. So if you have 2 perfect squares that go into something, when you multiply it, it's going to give you another perfect square. Super cool. All right, stop the video, try the first row 100% on your own. Now the practice problems, those problems, there are some that are already simplified that you can't do anything with, just to let you know. So stop the video, try 1 through 4, and then I'll show you the answers. All right, here you go. So if you notice, I got 2 square root of 2, 2 square root of 30. Number 3, there's a couple different ways you could do this. Again, there are 3 different ways you could start this problem. I knew because it ended in two zeros that 100 went into it, but it also is divisible by 4. It is also divisible by 400. But since 400 wasn't on my perfect squares list, I didn't think about that. So I was like, oh, 100 goes. But I had to go further because 12 still had a perfect square that goes into it. Number 4 is already simplified. All right, so if you have time, I would say do the rest of the problems on this page. If you don't really have time or you're feeling like you really understand this, then choose to either do the odds or the evens to finish up this paper and then come back to check to see if you've got your answers right. So stop the video right now, try at least half of them, come back, see if you did them correctly. So here are your answers. Take a moment to see how you did. Number 9 and number 14, those were already perfect squares. 2500, remember the square root of 25 is 5, so the square root of 2500 is going to be 50. So that's one that I just knew off the top of my head. Now the rest of these, notice I came up with 144 here, I came up with 36 here. I was looking for the biggest perfect square on my list of perfect squares that I wrote down, right? If I can't figure it out immediately, I am using a calculator. Like I am taking my radicand and I'm just dividing it by the numbers on my perfect square list to see if I can find one that goes into it evenly. Number 15, I could have started with a much bigger perfect square. 9 times 25 is actually 225, and 220, the square root of 225 is 15. But you may not have seen 225 automatically, and it's also not on my list of perfect squares that I'm going to write down completely, right? So I started with 9 and then I did 25. You could have started with 25, then done 9. Either way, you could have also just started with 225 because maybe you found 225. Make sure if you have any questions, you put stars by those questions and you ask me about them next time I see you. Enjoy the rest of your day.